All right, day 89 of 100 Days of ML. Today I'll be implementing EfficientNet with using Python, and we'll see how it goes. I'm not sure if the EfficientNet is if there's like an actual architecture for EfficientNet, because when I was going over the paper, the whole thing is the fact that it's built based on an optimization. And let me actually take out the paper for reference. Okay, so here we go. In this paper, we systematically study model scaling, blah, blah, blah. Propose a new scaling method that uniformly scales all dimensions of width, depth, resolution in a simple yet highly effective compound coefficient. So that's the whole thing, right? The fact that, they're using the same ConvNet, but they introduced this custom compound coefficient, which is able to scale uniformly, the architecture uniformly. So it's not necessarily a new architecture that they're implementing. It's more of like a small change which is included into the architecture. So let's take a look at TensorFlow and see if they have anything. I think when I was checking this out, they have the library for TensorFlow. Why isn't this working? Sometimes Chrome's a little funky on, yeah, on Linux. Not the best, honestly. But I don't really want to switch over to Firefox. Okay, so here we go. The model is implemented in Keras. We can see EfficientNet here. And there's the different variations, B0 to B7, where B0 is just a standard architecture using little to nothing coefficients, and it gradually increases. The level of coefficients increases over the next few iterations that they did. If they have it on TensorFlow, then they should have it in the repository, and I'll check out their GitHub repo and see if I can find it there. And also, let's try to see if we can find custom EfficientNet architecture. And go from there. So essentially what I want to do here is, when I'm reading these papers from the ML Berkeley reading list and going over these different like models, right, transformers, YOLO, EfficientNet, I want to actually practice by implementing them using TensorFlow or PyTorch at the same time as reading them. That gives me the ability to not only just remember what the theory is, but also be able to physically implement and know how to program these models. I think that's the main goal here and for this video. Okay, this is just importing EfficientNet from somewhere. I want to build it custom. So yeah, here it's being just automatically imported. Like, I don't want to import a model and just use a pre-trained model. I want to build the architecture layer by layer. Maybe I could just replicate it using the paper. Sometimes that's what people do, essentially, for really new models that come out and which are being implemented in TensorFlow. What people do is that they go through these papers, state-of-the-art models, and they look at the architecture referenced into the paper, and then they try to reproduce the architecture as well as get reproduce the experiment results. And if they're able to do that, that model essentially gets inserted into the TensorFlow repository. Okay, they have an architecture section here. What I could do is just try to go based on this, but there's little to no information. It's very hard to produce an entire model just using what they've listed here. So they have a custom optimization, and I'm not sure how to implement that in TensorFlow. We can take a look at, I believe, B0 here. So 3x3, conv 6, 6, a bunch of conv layers, and then finally we have conv 1, 1, pooling, and FC. And all the resolutions and channels and layers are listed over here. Okay, so there's multiple layers in each block. Let me take a EfficientNet architecture. Let's try to look at an image and see if anyone's produced an image before. Okay. Ooh, Google AI blog. That's cool. Might be interesting to read. Right, I think this model was produced by people at Google AI. Okay, so here is the architecture. Open image in new tab. So these are the different blocks, mostly convolutional blocks, but different sizes. Goes through different pooling. I'm actually surprised that there's no pooling in between these conv blocks. Or am I getting confused here? Okay, the effectiveness of model baseline. So to further improve baseline network neural architecture search using the AutoML optimizes both accuracy and efficiency. Uses inverted bottleneck convolution, mobile inverted bottleneck convolution, similar to MobileNet and MaskNet, slightly larger due to an increased flop budget. Okay, so these aren't regular conv blocks then. We'll have to read up on what mobile... Is that mobile inverted convolution? Oh geez, do I need to read the paper on this? Residual block, and we have an inverted block here. So this is a regular convolution. We have a 3x3 that maps into 1. Essentially it takes vector summation and does pooling on that. Separable convolution block. Here we have it. Can't see that. 3x3 mapping in here. 1 by 1 mapping into here. Okay, yeah, so we just have multiple layers in this with linear bottleneck. I don't know what linear bottleneck is, but 3 by 3 goes into ReLU 1 by 1, and then 1 goes into this expansion layer. Okay, looks like I need to do more reading so far. But, okay, I don't know how far back I want to go with this. For one, I should start by rereading. Shoot, where is it? The EfficientNet paper? That's right here. The introduction to this. I think I skipped the introduction and related work, so definitely have to go through that now. It's going to give a lot more information about how to go about structuring the architecture. Okay, one sec, I'll be back. All right, I'm back. Just got an idea when I was gone, thinking, this series is coming to an end soon. I could probably start a new series where I just read papers and implement the papers in code. It actually sounds really fun and something I might consider. Boom, boom, boom. Okay, where was I? Yes, I was checking out the mobile inverted conv block in MobileNet. So I definitely have to read over the architecture once more because of the fact that, it's created using these mobile inverted bottleneck convolution blocks, and I have no idea how they're implemented. So here's what I'm gonna do. Tomorrow I have my final, so I don't want too much stress on what I'm gonna do tomorrow. I'll try to make it lightweight. Either that or what I'm gonna do is end up streaming after my final. But I'm not sure if that's a good idea. We'll see what I do. Gotta wake up early in the morning. Oh yeah, okay, that's great. It works perfectly. So I'll wake up early in the morning. I'll reread EfficientNet, go through the introduction and related work. That way I get a consensus of how the model is being architectured and what these inverted mobile blocks are. And I guess I'll have to go through MobileNet v2 because of the fact that it's built using a similar architecture to Mobile v2 and MASNet. I'll consider reading this as well. So that's a lot of things to do. I didn't really think it was going to have this much overhead. So that's the architecture. Let's see, we got an image here. Got that done. Figure out if it's possible to code using TensorFlow. That's a good question. Okay, so here we have MobileNet. But the thing is, how are those MB blocks implemented? I want to check using the TensorFlow repository. Here we go. Let's go into code, TensorFlow. Actually, it might be a quicker Google search. MB on block. Custom layers. Alright, it says residual block. I'll just read this in the meantime though. Right, so it wants me to create it using its custom. Okay, in that case, let me just search up if there's layers in Keras. Application layers, conv blocks, transpose, 2D, 1D. Max pooling. I don't think it exists. In that case, I have to check out the implementation for MobileNet. How do I... Here, is it this? How do I open up the code? There was a button to open this up on GitHub. Okay, TensorFlow API 2.5 Python. Let me see if I can find it. API. Nope. just search it? There we go, EfficientNet.py. You can open up EfficientNet, and let's also open up MobileNet v2. General architecture means for multiple cases, blah blah blah. We can use this as a reference to create the model, because essentially this is what our model is supposed to look like. BO return EfficientNet using EfficientNet, which is probably declared up here somewhere. All of this. Okay, so they custom built everything. Looks like that's what they did. Weights, input shape, tensor, blocks. They're using a conv2d for the layer. Interesting. Batch normalization, activation, 2D, dropout, dense. Okay. Just wanted to check how those MBConv blocks are being implemented, but it doesn't look... Oh, right here. There's something called inverted res block. Where's this being implemented from? It's custom made here. Looks like they're building it using conv2d and batch normalization followed by ReLU. Depth-wise, expand, project. Okay. So these MB blocks, is it the same thing as the inverted res block? Where is it? I don't understand how they get all of this, and nothing about that is written in the paper. It just says 3x3. So why is there so much code for a 3x3 block? So you have 2 econ block here, round filters, comma 3. It's added on top of the 0 padding. Okay, we have the padding here. set to x comma 3. And next up, I believe, is what? Channels 32. So I guess that's what the 32 is here. Filters. Okay, so we have our first 3x3 con block here, and we can see that if in the stage 1, essentially, I guess, we have to figure out how to replicate all of these blocks using TensorFlow in a way that it's not super complicated like they've given in the TensorFlow code over here. But that might be tricky because, I mean, what we're trying to do is basically do the same implementation, but if we're trying to make it simple, wouldn't the TensorFlow team have already like considered that? That might be a question that might I have to consider. Dropout tens. If include top. Okay, I think I need to do a lot more reading before I start this. First of all, I need to start from the bottom up. What I'll do is create a new repository for all my work and start by first implementing conv blocks, very simple conv blocks, and then moving up to residual blocks, and then on to these like linear bottleneck blocks, which I have no idea what they are. And then the inverted ReLU blocks used in MobileNet. Okay, we have some sort of starting ground. Let's go back here, update this. I wasn't able to start the implementation, but we're able to figure out like how it's going to be implemented. So h3 a90 read. What's this one called? MobileNet v2. That's it. We'll work our way from top bottom. So by looking at these complicated architectures that basically build upon convolution blocks, we'll look at them and then basically look at how that model is created and go down the list until we get to the fundamental layers and then work our way back up and implement it using TensorFlow. Okay, so that's it for today. I'll be back tomorrow. Most likely tomorrow is going to be a quick stream. because I have my final tomorrow, and then we'll see how it goes from there. Right.